My dear students, welcome back to our channel. In this video, I will be explaining the BCA third semester subject database design as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 3 first important short question is Relational Algebra. Relational algebra is a mathematical way to work with tables, relations, in a database. It provides a set of operations to retrieve, combine, or manipulate data without using SQL. Think of it as the formula or recipe to get the data you want. Key operations. 1. Select, sigma, pick rows that meet a condition. Example, sigma, course is equal to math, student, all students taking math. 2. Project, pi, pick specific columns. Example, pi, name, age, student, show only name and age. 3. Union, combine rows from two tables. 4. Difference, dash, find rows in one table but not the other. 5. Cartesian product, times, combine all rows of two tables. 6. Join, connect related tables based on a common attribute. Example. If we have a student table and a course table, we can use join to find which student is enrolled in which course. In simple words, relational algebra is like a toolbox for tables. With its operations, you can filter, select, combine, and organize data easily before even writing SQL queries. It is the foundation of all database queries. Next important short question is 2. What are the preliminaries of the relational algebra? Preliminaries of relational algebra. Before using relational algebra, it's important to understand some basic concepts called preliminaries. These help us know how tables, relations, and operations work. 1. Relation, table. A relation is a table with rows, tuples, and columns, attributes. Example. Student ID name course. 1. Ravi math. 2. Attribute, column. An attribute is a column in a table that describes data. Example, name, course, age. 3. Tuple, row. A tuple is a row in a table representing a single record. Example 1. Ravi, math. 4. Domain. Each attribute has a domain, which is the set of valid values it can take. Example, age can only be 1 to 100. 5. Degree and cardinality. Degree is equal to number of attributes in a relation. Cardinality is equal to number of tuples, rows. 6. Fundamental operations. Relational algebra uses operations like select, project, union, difference, Cartesian product, join to manipulate relations. In simple words, think of preliminaries as the ABC of relational algebra. If you know tables, rows, columns, and rules, you can easily apply algebra operations to get exactly the data you need. It's like knowing the ingredients before cooking a recipe. Next important short question is 3. Relational calculus. Relational calculus is a non-procedural way to query a database. Unlike relational algebra, which tells how to get the data, relational calculus tells what data you want without specifying the steps. Think of it as asking a question instead of giving a recipe. Types of relational calculus. 1. Tuple relational calculus, TRC. Uses tuples, rows, to specify conditions. Example, T vertical bar T student and T dot course is equal to math. Meaning, find all students whose course is math. 2. Domain relational calculus, DRC. Uses attributes, columns, instead of full tuples. Example, name vertical bar student ID, course, student, student ID, name, course, and course is equal to math. Meaning, find names of students taking math. Key idea. TRC and DRC describe data we want, not how to get it. Relational calculus is the theoretical foundation for SQL. In simple words, if relational algebra is like cooking step by step, relational calculus is like telling a chef what dish you want, and the chef figures out how to prepare it. It makes querying intuitive, flexible, and closer to natural language. Next important short question is 4. SQL, Structured Query Language. SQL is a special language used to communicate with databases. It allows you to create, modify, retrieve, and manage data in relational databases. Think of SQL as the voice you use to talk to the database. Key features of SQL. 1. Data Definition Language, DDL. Create or modify tables. Example, create table student, ID int, name varchar, 50, course varchar, 20. 2. Data Manipulation Language, DML. Insert, update, delete, and fetch data. Example, insert into student values, 1, Ravi, math. 3. Data Querying, retrieve data using select. Example, select name from student where course is equal to math. 4. Constraints, ensure data integrity, like primary key, foreign key. Why SQL is important? Works with all relational databases. Easy to learn and use. Can handle large amounts of data efficiently. Supports complex queries, joins, and aggregations. In simple words, SQL is like asking questions or giving commands to a smart assistant who understands tables. Want all math students? Just ask with select. Want to add a new student? Use insert. SQL makes databases easy, powerful, and interactive for everyone. Next important short question is 5. Queries. A query is a request to the database to fetch or manipulate data. In simple words, it's like asking a question to the database and getting an answer. Queries are the main way we interact with databases. Types of queries. 1. Simple query. Fetch data from a single table. Example, select name, course from student, shows names and courses of all students. 2. Conditional query. Fetch data with a condition. Example, select name from student where course is equal to math, shows only students in math. 3. Join query. Fetch data from multiple tables using relationships. Example, select student.name, course.coursename. From student join course on student.courseid is equal to course.courseid. Shows which student is enrolled in which course. 4. Aggregate query. Calculate totals, averages, etc. Example, select count, asterisk, from student where course is equal to math, number of students in math. In simple words, queries are like asking your database for exactly what you want, whether it's a list, a count, or a combination of information from multiple tables. They make databases interactive and powerful, turning raw data into useful answers. Next important short question is 6. Constraints. In databases, constraints are rules that control the kind of data that can be stored in a table. They ensure that the data is accurate, consistent, and reliable. Think of constraints as traffic rules for your database. Without them, data can get messy and chaotic. Common types of constraints. 1. Primary key. PK uniquely identifies each row in a table. Example, student ID in student table must be unique. 2. Foreign key. FK ensures a value in one table matches a value in another table. Example, course ID in enrollment table must exist in course table. 3. Unique. No two rows can have the same value in this column. 4. Not null. Column must always have a value. 5. Check ensures values meet a condition. Example, age 0. Example in SQL. Create table student. Student ID int primary key. Name varchar 50 not null. Age int check age 0. In simple words, constraints are like rules in a classroom. They prevent mistakes, make data trustworthy, and ensure the database behaves properly. They keep the database clean, safe, and reliable. Next important short question is 7. Triggers. A trigger is a special kind of database rule that automatically executes an action when a specific event happens in a table. Think of it as a watchful assistant that reacts immediately when something changes in the database. Key points about triggers. 1. Event-driven. Trigger activates on events like insert, update, or delete. 2. Automatic. No need to manually run a query, it runs by itself. 3. Purpose. Ensures data integrity, auditing, or automatic updates. Example. Suppose we have a student table with total marks. We want to update the grade automatically whenever total marks changes. Create trigger update grade. After update on student. For each row. Begin. If new.total marks is equal to 90, then set new.grade is equal to A. Else if new.total marks is equal to 75, then set new.grade is equal to B. End if. End. When a student's marks are updated, the trigger automatically assigns the correct grade. In simple words, a trigger is like a smart robot in your database. It watches for changes and performs tasks automatically, saving time and avoiding human errors. It makes the database active and intelligent. Next, Unit 3. Long questions. First important long question is expressive power of algebra and calculus. The expressive power of a query language refers to how effectively it can express the queries we want to perform on a database. In other words, it measures what kinds of questions can be asked and answered using the language. In databases, we usually compare the expressive power of relational algebra and relational calculus. 1. Relational algebra. Procedural language tells the database how to get the result step by step. It can perform basic operations like select, project, join, union, difference, Cartesian product. Using these operations, we can retrieve almost any query that can be expressed in relational calculus. Example. Find all students enrolled in math. Sigma course is equal to math student. This tells exactly which operation to perform to get the result. 2. Relational calculus. Non-procedural language tells the database what result we want, not how to get it. Comes in two forms: tuple relational calculus, TRC, and domain relational calculus, DRC. Expressive power is equivalent to relational algebra, meaning it can describe the same queries but in a declarative way. Example, TRC. Find all students enrolled in math. T vertical bar T student and T dot course is equal to math. Here, we describe the condition without specifying steps. 3. Comparison and importance. Both can express the same set of queries, so their expressive power is considered equivalent. Relational algebra is useful for implementation, while relational calculus is closer to how we naturally think about data. Understanding expressive power helps database designers choose the right approach for querying. In simple words, think of relational algebra as a step-by-step cooking recipe, while relational calculus is like saying, I want a chocolate cake, the chef decides the steps. Both methods can get the same result, but one focuses on how and the other on what. This concept is crucial because it shows that databases are flexible. You can ask complex questions in different ways and still get correct, reliable answers. Next important long question is: two set operators. In databases, set operators are used to combine results from two or more tables. These operators are based on mathematical set theory, where tables are treated as sets of rows, tuples. They help in performing operations like union, intersection, and difference on tables to get meaningful results. 1. Union combines rows from two tables and removes duplicates. Both tables must have the same number of columns and compatible data types. Example: Table A, Math students. Name: Ravi, Priya. Table B, Science students. Name: Amit, Priya. AB. Name: Ravi, Priya, Amit. 2. Intersection gives only the rows common to both tables. Example: AB. Name: Priya. 3. Difference gives rows that are in the first table but not in the second. Example: AB. Name: Ravi. 4. Cartesian product times, sometimes included in set operations, combines every row of one table with every row of another table. Useful for joins and advanced queries. Why set operators are important? Combine and filter data from multiple tables easily. Support complex queries without repeating steps. Basis for SQL commands like union, intersect, and except. In simple words, think of tables as baskets of fruits. Union is equal to take all fruits from both baskets, remove duplicates. Intersection is equal to only the fruits that are in both baskets. Difference is equal to fruits only in the first basket, not the second. Set operators make working with multiple tables easy and efficient, turning raw data into the exact results you need. Next important long question is: 3. Nested queries. A nested query, also called a subquery, is a query inside another query. It allows you to use the result of one query as input for another. Think of it as asking a question inside a question. Nested queries are very useful when you need complex results from multiple steps. How nested queries work? The inner query executes first and produces a result. The outer query then uses that result to fetch the final data. Example 1. Finding students in the top course. Suppose we have a table student. Student ID, name, course ID, marks. 1. Ravi 185. 2. Priya 190. 3. Amit 195. We want to find students who scored the highest marks. Select name. From student. Where marks is equal to, select max, marks, from student. Inner query, select max, marks, from student, finds 95. Outer query, fetches the students with 95 marks, Amit. Example 2. Using in with nested query. Select name. From student. Where course ID in, select course ID from course where department is equal to science. Fetches all students enrolled in science courses. Inner query finds science course seeds, outer query finds students in those courses. Why nested queries are important. 1. Handle complex conditions easily. 2. Combine multiple tables logically. 3. Reduce the need for temporary tables or multiple steps. In simple words, nested queries are like Russian dolls, a small doll inside a bigger one. The inner query solves a smaller question, and the outer query uses that answer to solve the main question. This makes database querying powerful, efficient, and easy to manage. Nested queries are essential for intermediate to advanced SQL tasks, helping you ask precise questions and get exactly the data you need. Next important long question is 4. Aggregate operators. Aggregate operators in databases are special functions that perform calculations on multiple rows of a table and return a single summarized value. They are very useful for analyzing data, like finding totals, averages, or counts. Common aggregate operators in SQL. 1. Count counts the number of rows that match a condition. Example, select count asterisk from student counts all students. 2. Sum adds values in a numeric column. Example, select sum marks from student total marks of all students. 3. Average calculates the average value. Example, select average marks from student average marks. 4. Min finds the smallest value in a column. Example, select min marks from student lowest marks. 5. Max finds the largest value in a column. Example, select max marks from student highest marks. Using group by with aggregate operators. Aggregate operators can be used with group by to calculate summaries for each group. Example, find average marks per course. Select course ID, average marks from student. Group by course ID. This gives the average marks for each course, not for the whole table. Why aggregate operators are important. 1. Quickly summarize large data. 2. Support decision-making in reports and analytics. 3. Reduce the need for manual calculations. In simple words, think of aggregate operators as smart calculators for your database. Count counts the students. Sum adds all the marks. Average tells the average. Min and max find extremes. They help you see the big picture from raw data. For example, in a school database, you can find top scorers, average marks, or total students in each class with just one query. Aggregate operators make databases powerful tools for analysis, turning raw numbers into useful insights quickly and easily. Next important long question is 5. Procedures and functions. In databases, procedures and functions are types of stored programs that allow us to perform tasks repeatedly without rewriting queries. They are written once and stored in the database for reusable and efficient operations. Think of them as custom commands that the database can execute whenever needed. 1. Procedures. A procedure is a set of SQL statements that perform an action but may or may not return a value. It can accept input parameters and sometimes provide output parameters. Procedures are usually used for tasks like updating records, inserting data, or complex calculations. Example, insert a new student into the student table. Create procedure add student in SID int, ins name varchar 50, in course varchar 20. Begin. Insert into student, student ID, name, course, values, SID, name, course. End. Now, calling add student for Anita, math, will add a new student automatically. 2. Functions. A function is similar to a procedure but always returns a value. Functions are commonly used for calculations or transforming data. Example, calculate grade from marks. Create function getGrade, MINT, returns varchar 2. Begin. Declare grade varchar 2. If m is equal to 90, then set grade is equal to a. Else if m is equal to 75, then set grade is equal to b. Else set grade is equal to c. And if return grade. End. Calling select getGrade 85 returns b. Key differences. Feature procedure function. Returns value optional mandatory. Can be called in SQL query no yes. Purpose actions tasks calculations. In simple words, think of a procedure as a robot that does tasks, like adding students or updating marks, while a function is a smart calculator that takes input and gives a result, like calculating grades. Using procedures and functions makes databases smarter, faster, and less error-prone, especially for repetitive operations. They save time and help maintain consistency in data handling.